Travis Hernandez, or Miss H, and some of you I do know, and some of you have done this a couple times. This is your probably second time going through an honors anatomy lecture. I'm going to give you the brief, rough, edited version of this. So from what I hear, you guys have been learning about sound and kind of how it works in terms of the ear and stuff like that. How many of you guys took anatomy or honors anatomy? Okay, so a couple. Okay, so this is what your inner ear structure looks like. Obviously, you've got your earlobe right here, which is actually technically medically referred to as what's known as the pinna. And it's spelt like so. And what do you think the pinna does? What is its function?
Sound.
It collects sound, right? And have you guys ever done coyote ears or rabbit ears before? Where you just kind of cup your ears, make little C's, cup your ears, and go ahead and just listen. And then go ahead and remove those little C's. And you'll notice the change. I'm not changing my tone or my pitch or my volume that I'm speaking to you. So what ends up happening is, and technically this is true, larger ears you have, typically the better collection of sound, which could potentially be related to a better hearing, right? Now what ends up happening is the sound gets collected by the pinna, travels down what's known as the auditory canal. I should label all these. And the auditory canal is literally just a funnel. And all it's doing is it's just directing the sound directly to where it has to go to. And the auditory canal is going to send the sound, the vibrations, to where? To the eardrum. Yeah.
The drum.
The eardrum. And the eardrum is also sometimes referred to as the tympanic membrane. Anybody in here a musician? Familiar with music? What's the big drum that they use?
Bass drum.
The tympanum, right? The tympanum is the one, and kind of the same function with the tympanic membrane. As soon as there's something that activates it, some type of force, some type of vibration, that vibration is then going to be resonated throughout your eardrum. And this is where kind of the start of the transmission of sound takes place. So what ends up happening is that vibrating tympanic membrane is going to then vibrate the smallest bones in your body. And these are a couple of different ones. You've got 3 bones. All of them can fit on the head of a penny together and still not fill up that thing. If you've ever had, has anybody ever ruptured their eardrum? Maybe, yeah. It's pretty painful. It can actually cause you to go deaf or impact your hearing for the rest of your life. And the reason for this is because of these little bones that are in the back. These little bones transmit that sound vibration directly to kind of the nerve area where sound gets translated from a vibration, literally a wave movement, into a nerve impulse. And so we won't go into the specifics of these bones, but we'll just go ahead and say these are called the auditory ossicles. So anytime you see auditory, you know it's relating directly to your hearing. And then you can think about like ossification as just being bone structures. So these auditory ossicles are going to vibrate, and they vibrate kind of consecutively. So like the first bone vibrates, it causes the middle bone to vibrate, and then that's going to go ahead and cause the third bone to vibrate. And this third bone is actually on another membrane. And that membrane is called the oval window. Now when the oval window vibrates, it's directly connected to a structure that looks like a snail shell and is called the cochlea. Alright? Now the cochlea is actually a fluid-filled chamber. So you can kind of see here, once I erase this stuff. It's got both solid tissue, it's got air inside of it, it's got these little hair cells, which are literally kind of like minute hairs that exist within your ear, and it's got a lot of fluid inside of it. So this is kind of zoomed in, so if I kind of reorient you, you've got your auditory canal, you've got that tympanic membrane, or eardrum. You've got the 3 auditory ossicles. Well, that's supposed to be not like that. These are your auditory ossicles. And this right here is that oval window. This structure is that cochlea, or that snail cell. So what ends up happening here is this is showing you now these little arrows that are going through. That's the vibration, that sound that's kind of traveling through. So it hits the tympanic membrane, vibrates the first auditory ossicle to the second to the third, vibrates the oval window, and now this kind of dotted stuff that you see right here, that is the liquid that's in the cochlea. And that liquid then transmits that vibrational sound. And what happens to sound as it travels in water versus traveling through air? What happens? It accelerates? Yeah. So what ends up happening, but it also at the same time will disperse, correct? Like in air, it's typically the particles that it bounces off of, even though they're further apart, there's not as much dispersion of that sound. So it accelerates because the particles are closer, but at the same time, it's also going to kind of disperse out a little bit. So this is why when you're underwater and somebody yells at you, you know that somebody's yelling, but you have no clue which direction they're coming from, correct? But if you're out in the hallway and somebody yells at you and they're back here, chances are pretty good you're going to be able to turn around and be like, somebody called me from over here versus somebody called me from in front of me, right? So what ends up happening is this just allows that sound to kind of speed up and get to where it ultimately has to go. And then what ends up happening in its ultimate destination is this little area right here, this horseshoe. It's got 2 layers and then it's got these little hairs in between. I'm going to go ahead and zoom in on that section. Now this is a close-up of just one small section of that horseshoe. And you've got this out here would be the cochlear fluid. You've got a membrane on the bottom. You've got a membrane on the top. And then you've got these little cells in the center that are called hair cells. For you guys, I'm just going to go ahead and say this is membrane 1. This is membrane 2. And this right here, I'll just go ahead and say is your hearing nerve. That's fancy term for this is the vestibulocochlear nerve. And what ends up happening is the sound is going to hit membrane 1. That sound then gets absorbed by this solid tissue. And what ends up happening is that solid tissue doesn't just absorb it and stay in one state. It's going to go ahead and respond to that. And the response is going to be a movement. And that movement is going to be a movement up. All right? So that sound vibration now is actually causing this membrane to go ahead and move up. Anything that sits on top of that membrane is then going to be obviously pushed up as well, right? And that's going to be where these little hair cells get pushed up. They automatically kind of get squished on membrane 2. And then that squishing or that action, that movement action, actually is what generates an electrical impulse. And the result, the reason why that happens is because of frictional force. So these little hairs pushing against this membrane is going to create a friction. That friction is going to create an electronic charge, which generates the initial impulse for this nerve impulse to go. These little hairs directly connected to that hearing nerve, or that auditory nerve. So as soon as that electrical impulse is generated by these little hairs rubbing against this membrane, it now sends this directly to your brain. So this nerve is one of your primary nerves. You have 12 neural nerves that are associated with all the movements of your body. This is your hearing one. So as soon as this one's activated, you then have the sound transmitted. Every once in a while you have people that have issues with this, and this can be the cause of a variety of different deafnesses that'll take place. They could be missing any part of that relay that we just talked about right now. All right, it was quick, there's a lot, but I hope it gives you a little bit more insight into how hearing works. And that's it.